Hello there. So today we are going to do our notes on recursive and explicit arithmetic sequences. So yesterday we talked about arithmetic sequences and how they are a rule that will help you find the next number in a sequence that the same amount has been taken away or added. And there's two ways that you can write those rules. You can write them as recursive or as just a function. So the recursive way is when you think of starting from the last number that you know, you can find the next one by the repeating pattern. So if the same number is being added or taken away from the previous number to get to the next number, well, as long as you know the one before, you can figure out which one comes next. And this is good to find the first few numbers, but if I wanted you to find the 100th number that came in a sequence, doing it recursively would take a long time because you'd have to know what came first to know what comes next, and on and so forth. And so there's two ways that you can do this. We're going to look at the recursive way first, which is typically easier because it already is annotated like a function that we talked about, or like a sequence that we talked about yesterday. So if we have a sequence of numbers here, 100, 95, 90, 85, 80, what we find is that this is the first term, the second term, the third term, the fourth term, and the fifth term. And every single time, what's happening is 5 is being taken away. Every single time. So that's our common difference right there, minus 5. So to write that recursively, you write your first term and the rule. Every time. Recursive has two parts. You need to know the first term and the rule. So just like yesterday with the sequences that I gave you guys, I gave you a rule and I gave you the first term, and you were able to find what comes next because you knew what came before. So with recursion, you can never know what comes next unless you know what came before it. So they have to give you a starting point. And that's what the first term is. It's a starting point. So the first term in this sequence is 100. So we'll fill that in. Now to write the rule, this is the rule you use to find the next number. The way that you write it is a sub n minus 1. So you know how we have a sub 1, a sub n? Well, for this, you're going to write a sub n minus 1. And then you put the difference here. The difference in each number was minus 5. And what this whole term right here means, a sub n minus 1, it literally means previous term. Because no matter what number you put here, so if I wanted to know what the sixth number would be, and if I put 6 here, well, what is 6 minus 1? It's 5. So this would actually be a sub 5, which is 80. So to find the next term, it's going to take me back to the previous term, and then it's going to take 5 away. So to find a sub 6, if I were to put 6 in here, if I was looking for the sixth term and it said a sub 6, and I plug 6 in place of the n, 6 minus 1 is 5. That's a sub 5. That's 80. That's the previous term to a sub 6. So no matter what number you put in here, when you take one away, it's always going to take you back to the previous term. So in order to find what comes next, you go back a term and apply the difference. So in order to figure out what came after 85, which is 80, you can't start here. You have to go back, start here, take 5 away, and then you get to a sub 5. So if we were solving for a sub 5 and trying to figure out, 80, we'd have to start back here at 85 and take 5 away. If we were trying to solve for 85, we can't start here. We have to start at the previous term, take 5 away, and then get there. So recursion is really good to find the first few terms because you have to go back to the term before it to find the next term. But we don't want to do that a million times over to find the 52nd term in a sequence. So this is really good for the first few numbers of a sequence. So this next example, they've given you the sequence and they want you to write the recursive rule. So 5 is the first term, 8 is the second term, 11 is the third term, 14 is the fourth term, and 17 is the fifth term. So these are first, second, third, fourth, fifth numbers in the sequence. What's happening between each number? How do I get from 5 to 8? What's the difference? We add 3. What about 8 to 11? We add 3. 11 to 14, we add 3. And 14 to 17, we add 3. Remember, the difference has to be the same every time in order for it to be arithmetic. It has to be a common difference. You can't just add 3, then add 8, then add 10. It's changing. You have to have a rule, and it has to stay the same. So to write this recursively, the first term of the sequence is 5, and the rule is going to be previous term and the difference. The difference is plus 3 this time. Every time, this is how it gets written recursively. So now the last example, I've given you guys a recursive the recursive formula right here. And what I want you to do now is to tell me what the sequence is. Okay? So if I know the first term is 6, I can write 6 down. That's the first term. What's the next term? Well, let's find out. Let's make our little table. The first term was 6. The second term, if I plug it into this rule, that would be a sub 2 minus 1 plus 5, which would simplify down to a sub 1 plus 5, right? Because 2 minus 1 is 1. And what is a sub 1? Well, that just told us. Previous term. The previous term was 6. So that's really 6 plus 5. What is 6 plus 5? 11. What about the third term of this function? So that would be a sub 3 minus 1 plus 5. I'm not going to do equals. I'm going to do an arrow. Well, what is 3 minus 1? That's 2. So that's a sub 2 plus 5. And what is a sub 2? Well, it just told us. The second term was 9. So that's going to simplify down to 9 plus 5. Not 9, I'm sorry, that's an A. 11. I do apologize for that. 6 plus 5 was the second term, which was 11. So then we get down to 11 plus 5, which is 16. So what you're noticing is the previous term plus 5. 6 to 11 to 16. What's going to come next? I'm going to add 5. Every time I'm adding 5. What's 16 plus 5? And then what's 21 plus 5? And again, just to be sure, we can come over here and write it out. The fourth term, so if I had a sub 4 and I was plugging 4 into this rule, it would be a sub 4 minus 1 plus 5, which would simplify down to a sub 3 plus 5. And a sub 3 stands for the third term in this function, or sequence, I'm sorry, which is 16 plus 5, which will give me 21. So the fourth term should be 21, and it is. The fifth term should be 26 if we did everything right. So let's check it out. If we do a sub 5, we put 5 right there, a sub 5 minus 1 plus 5. Well, a sub 5 minus 1 is going to reduce down to a sub 4 plus 5. And a sub 4 stands for the fourth term in the sequence. The fourth term in the sequence was 16 plus 5 was 21. So 21 plus 5, 26. Yeah. So every time you basically take previous term plus 5. Previous term, 6 plus 5 plus 5. Previous term. So for the fifth term, we started with a sub 4 and added 5. For the fourth term, we started with the third and added 5. For the third term, we started with the second and added 5. So literally, a sub n minus 1 stands for previous term. You just take the number before it and add or subtract whatever your difference is. This is just the actual math behind why it works. So recursion is the easier way to write it. You start with the first number, and then you always write a sub n minus 1, and you find whatever your difference is. Now, explicit arithmetic sequences are a little bit more challenging because there's, I guess, more to remember. But they can be used as a function, right? It's a rule. You can find any term in this sequence without having to know the one that came before it. You don't have to go back to the previous term to find this one. I can use this rule to find any term. So again, just to clarify, this is the rule that we're going to follow now. So recursion has two parts, a sub 1, a sub n. Explicit just has one part, a sub n. So a sub n just stands for the value of the nth term. You can change that n value to anything, but if you leave it open, it means that that rule can be used as is for any number. N stands for the term number, not that number in that spot, but the term number itself. A sub 1 is the first term, and d is the difference. So if we look at this first example, we have 6, 10, 14, 18. So it's like, that's lots of stuff there. Let's figure it out. What is the difference? From 6 to 10, from 10 to 14, from 14 to 18. The difference every time is 4. So our difference is 4. The first term is 6. And they want to find the 12th term in the sequence. So if we have this information, let's plug it into our rule. D is 4. N minus 1, so they want us to find the 12th term. So for n, right here, you plug in whatever number you're looking for, right? So if they wanted us to find the 12th term, I'm going to change that, a sub 12, 12 gets plugged in for the n. So we have d parentheses n minus 1 plus a sub 1. So we're going to plug in 12. That's the n value they want us to find. Take 1 away and add the first term, which is 6. Well, 12 minus 1 is 11, so we end up with 4 times 11 plus 6. And then 4 times 11 is 44 plus 6, which is 50. So the 12th term in this sequence is 50. So I didn't have to sit here and do this 12 times to figure out what the 12th number would be. I can just use the explicit function rule. The last example real quick is, here's our sequence, and we're going to find the 10th term. So I'm going to change this to say 10. So if this is our function, or our sequence, excuse me, I keep wanting to say function. First, we have to find the difference from one number to the next number. And the difference, it looks like, is 5. So we're adding 5 every time. So the difference is positive 5. Oh, I should have put a positive right there. The first term is 52. And they want to find the 10th term. So we're going to use the rule. This rule every time. This is the rule we use, and we plug everything in. So we have D comes first, which is positive 5. N minus 1, which is 10, because we're looking for the 10th term. And then we put our difference at the end, so positive 5. So 10 minus 1 is actually 9. 5 times 9 is 45 plus 5. What do you know? The 10th term in this one is 50 as well. So it might be quicker to find terms that are far, far, far away in a sequence if you use the explicit form. So as long as you can find the difference in the first term, you can either write the explicit formula or you can write it recursively if you know the difference in the first term. So there's two ways you can write these sequence functions, as recursion or as explicit as well. So you can either write recursively or explicitly, depending on what your needs are. So I know that that video is a little bit longer and probably a lot of information, but we're going to practice both of these, and then you'll be able to fly through them, and they'll be super easy. So thank you guys for copying these notes down, and we will talk later whenever we practice.